All right, I don't think video number 2 has gone viral yet. Maybe video number 3 is going to be the one to do it. Let's break the internet. All right, so we did a lot of fun and exciting things, hopefully also a little bit educational. On the last 2 videos, let's summarize everything that might happen. Now, here's the thing. I purposely didn't do any problems like this because it's what we did in lessons 11.1 to 11.6. But there are going to be some problems where you actually use your area formulas and then just make a ratio. So that might happen if I ask you to compare 2 shapes that aren't even the same shape, a square to a hexagon or something like that. Find 2 areas and just make a ratio. So that's awesome. Now, sometimes that's not going to be possible. So now you're going to ask yourself some questions. Do my 2 figures have the same base? Or do they have the same height? And then that's what we did in video 1. I can't spell. All right. And maybe they have the same base and the same height, and you know what to do there because we talked about it. But sometimes that's not going to apply. So the third and final question you ask yourselves, do I have similar figures? In which case you get to use what we did in video 2, and we'll take the square of the ratios of corresponding sides. All right, now if you want to try these problems on your own, pause the video and then come back. But this is too fun, I can't stop, so let's just do some math right here. Here are some very popular problems. You'll see lots of different versions of these from now until the end of the year. So let's take a look. Situation number 1 actually goes back to chapter 10. Those inscribed angles that intercept the same arc have to be congruent. We have the vertical angles, but we don't even need them. So the first thing that you're going to tell yourself, ooh, those are similar triangles. So now I have to make a ratio of the corresponding sides, but you have to use your brain very carefully to make sure you line up those corresponding sides. In the case of this picture, the 5 lines up to the 7, and we're going to square that to get 25 over 49. End of story. The only other thing I'll mention on these kind of problems, the 5 to 7 fraction is already lowest terms. That's when I would square it. If I had something like 10 over 12, I would reduce that first before squaring it, and then it'll be easier to reduce your answer in the end. All right, number 2, there's 2 things that might occur to you. You might look at the triangles and say, oh, they have the same base, but they also have the same height. So you might say that to yourself. And so you know they have the same area. Or you might also say that, oh, you know what, hold on. That's that median theorem that we talked about. So it doesn't matter what thought process you use, as long as you realize the ratio is 1 to 1. And if you want to write 1 over 1, that's fine too. All right, I purposely put number 3 on here to make it look like a bow tie, just like number 1, except this is a chapter 8 bow tie and not a chapter 10 bow tie. So those parallel lines are going to give you some alternate interior angles congruent, so the triangles are similar by angle. And I do know, so I'm going to write down similar triangles, yay. And so ratio of area 1 to area 2 is the ratio of the sides squared. So I do have to line them up correctly, and that's going to be a 10 over a 7, and that will be 100 over 49. End of story. Beautiful. All right, everyone's good friend Elizabeth. It's springtime, so it's time for that garden. Right now it's 3 meters on a side. How long would she have to make the sides of the new garden if she wants to double the area? So there's not a single correct way to do this one. I know where my brain takes me. Maybe you go the same direction. Maybe you do something else. First thing I would figure out is with the current garden, the area is 3 squared, so the area is 9. Now she wants to double that area. So the new area is 18, and now I'm going to go back to lesson 11.1 or 11.2, and I know that side squared is the area, so plus minus, except negative garden, that's sad. No one wants a negative garden. So we're going to call that a 3 root 2, and nobody wants to lose points. This is meters, so I'll put my meters. If you want to give a decimal, fine. Who has time to press buttons on a calculator if you don't have to? And our final question will show up now and probably again in future chapters. two circles have radii of 3 feet and 5 feet. Find the ratio of their areas. So I didn't mention this anywhere in any of the videos yet, but hopefully you realize that all circles are similar. And so as soon as you realize the similarity problem, then you know that the ratio of the areas will be the ratio of their, instead of sides, it'll be the ratio of the radii squared. So that's going to be a 9 over 25, and ratios don't have units, so that's the end of the story. And I hope you enjoyed lesson 11.7. We have an entire second day of just practice problems. These things are important, and they will keep coming back in future lessons. So please reach out if you need help. I love you, and I'm here for you.